Hello, everybody. I'm Marie, as you already heard. And I want to talk about building games with Ruby today. So about me, that's me. I'm a developer since about 10 years now, and most of the time backend. In my free time, I'm a wilderness and survival trainer. I really like video games, and I do a bunch of other weird stuff. So just my path so far, since I quickly mentioned it, it actually started in social sciences. I did my master's and I kind of got bored with writing my master's thesis, and I treated myself with learning to code in parallel, which was a super nice treat. And so I ended up, instead of going the science route, starting as a QA person. And in parallel, kept learning coding. So eventually I became a front-end developer. In JavaScript, I think for someone who has never coded in their entire life, HTML, CSS, JavaScript is one of the easiest entryways. The problem was I've been a front-end developer for about a year, and I realized I don't care if stuff is pretty. I don't care how stuff looks. And this is not a good trait for a front-end developer. I'm excited about stuff being, like fast, performant, elegant code. So I kind of took the tool that I had and went into backend. And I've been a Node.js developer for another year until another startup that I've been working for went bankrupt, as they so often do. And, well, ended up applying at myself, where I've been for a long time as a Ruby on Rails developer. Now, looking at this path, you might notice something. I went from JavaScript to Node.js to Rails. The problem is there's a bit of a gap in between. I never learned Ruby. So I realized I became a Rails dev before I was a Ruby dev. And I thought, okay, I should learn the language that I'm using. So why not just write some Ruby code for a change? Can you all read this? Yes. Okay, so who notices a problem here? Someone?
Present. Yeah. Oh no.
Computer says no. That was the moment when I realized I should really learn some Ruby. But I thought, okay, if I'm going to do a side project, why not do something fun? Why not just do something nice that is also, like just not a project for the sake of coding? So maybe building a game, maybe I don't know, like. And then I was sitting there doing my usual thingies in the newspaper. So we could create a Sudoku. How hard can it be, right? So let's do a Sudoku generator. How do you actually create a Sudoku? Next question. You start with a grid. Obviously, it's like 3 times 3 times 3 times 3 grid. You could also say 9 times 9. And this is how you start. Then you can fill out the diagonals with random numbers. Why do you do that? Because they don't interfere with each other, so you can just randomly put them in. Easy, nice, fast. Next step, you fill out the whole thing according to the rules of Sudoku. I mean, I guess you all know them, right? You don't want to have overlapping numbers in the rows, in the columns, and per square. And then you basically have your Sudoku ready, and all you need to do is remove stuff again. Bam, it's done. So with this, you want to translate that logic into code, and it's pretty straightforward. I really hope it's somewhat readable. What we see here is just we have an array of arrays. And that's our grid. We fill them up with random numbers. That's a solution. And we remove them again. And we have our Sudoku. And then all we need to do is somehow put this into something that you can read. So we want to print it. We want to draw something in the terminal because plain Ruby, nothing else. We draw a line, we add a couple of separators, we add a couple of like empty spots where we want to fill out the numbers. And boom, we have our Sudoku. And that's the whole story. It's really as simple as that. But the thing is, who actually wants to play a Sudoku printed in the terminal? I mean, you could do a screenshot, I guess, and fill it out, but let's be real. So why not make it interactive? While staying in the terminal, by the way, and still in plain Ruby without any additional stuff. So what do we actually need to achieve this? We need some UI rendering. We need to see something. We need something to interact with. We need logic, obviously. We have to generate the thing, and we have to deal with the stuff that comes in. We need a state. State is basically all the data that is persisted. We need to know what the current board is. We need to know what numbers a user already put in. And of course, the user input. We need to put in numbers. And finally, we have a game loop, which is basically, in this case, user interaction per user interaction. So it can be like as long as or as short as you would like, but it's like one loop of the game is user doing something to the next time user's doing something. So about the UI and the rendering, we already have a grid. We just make it a bit bigger to be like nicer for interacting with it. We can add a title to the right and a difficulty. Now we need the logic. It's not that much. We basically already have our board created, and all additional stuff that we need is we need to start a game, we need to validate the input, ensure uniqueness, which is kind of important now, because if we want the user to be able to compare their solution with our solution, it should be unique. Otherwise, we run into problems. Before, we just generated something, and technically, we didn't make sure if you'd have a 6 here and a 4 there, or a 6 here and a 4 there. Like often, couples of numbers can be interchangeable. We don't want that here. So for the state, also pretty straightforward. We have a board, we have a solution. All we need is remember where the current position of the cursor is and the numbers the user entered, obviously. And for the user input, yeah, that's when it got painful. Like, these codes is something that I never wanted to know about. And this is also the reason why I created a bunch of constants, because for my life, I wasn't able to remember if 31 is red or 32. It's just, yeah. But I put them together. I mean, technically, the colors are part of the rendering and UI topic, but since it's the same logic, it's the same codes, I wanted to show them together. And this is the stuff that you're working with. And the nice thing is, you can literally print out colorful messages. You can literally go to your terminal right now, add these \E something, and you can create colorful text. And this is the coolest thing ever. I had no idea, and I love it. So now we handle the user input, and it's actually really straightforward, really nice. We have the arrow keys, we have the numbers, and a couple of additional stuff like deleting the numbers that you put in or quitting the game, starting a new one, yada, yada. And for moving up, down, you can see it's just, we remember the coordinates and we move the cursor accordingly. And we also make sure that they don't move the cursor, I don't know, like somewhere into oblivion, or put in some random text instead of the numbers. And in the end, you can see for input number that we also validate if they're allowed to write something there, because if it's a pre-filled cell, obviously they're not supposed to do anything there. And this is basically our game loop as well. All right, terminal time. So here we have, why is this in the, I know I have too many, I know. I just have to drag this down. Okay, almost, yes, we're back. So we basically have our print version, just as nice here. We can also add a difficulty level, make it a bit harder, and it prints it out. And now we start the interactive mode. We again select difficulty. Let's make it hard because we like a challenge. And boom, there it is. And it's colorful. I mean, it's not so easy to see it now, but well, you put in the numbers. You can check your solution. Obviously, it's very incorrect at the moment. And yeah, it's like, this is all there is to it. It's an interactive terminal game, completely in Ruby without any additional chants or anything else, just like that. Cool. Okay. So, well, nice and all. But what about an actual game? I mean, this is like, you could call it a game, but you know what I mean. So, what do I do? It's just, I wanted to produce something that is helping me learn proper Ruby, but on the same hand, I wanted to have something that's fun, that's also not going to take me thousands of years, and that I will actually end up playing, because what's the point of creating a game when you don't play it, right? So I remember this thing. Does anyone not know this dinosaur? Good. So I love it so much. And I thought, like, okay, this is super easy, super straightforward. Let's do that thing. I mean, not exactly that thing, because so many people, you can look it up online, recreated this thing. But still, I mean, it's nice, and maybe I could pair it with something I really like. For example, who doesn't know this symbol? Legend of Zelda. So why not have, I don't know, Link run through the, I don't know, Lost Woods and jumped over a bunch of Octoroks and keys. Because why not? So I was wondering. And then our Lord and Savior, Johannes, came up to me and was like, have you heard about this Gosu? I was like, no, what is this Gosu you're talking about? Gosu is like an ancient gem. It's so old. But the thing is, it's doing exactly what I needed. It gives you a super simple, straightforward game environment. You have a window, you have handling for the graphics and the input and even sound. And so I was like, sure, let's give it a try. So what do we need? I remember this because it's basically the same structure, just like in the Sudoku game, just way more fancy, except for one aspect, but the rest way more fancy. So again, let's start with UI and rendering. And this is basically all there is to it. You require the gem and you show a window. Boom, you have your game window. I mean, it's black and it doesn't do anything, but it's there. And then you need some visuals and some sounds, you know, you want to add sprites, for example, like this stuff for someone who's really hyper-focusing on pixel art at the time. This is very convenient. You want to add a couple of backgrounds, or like actually one background, but you want to make it very long so it doesn't repeat all the time, but then you need to make sure that when it repeats, it's not visible, because you want to have like the illusion of a loop, of endlessness. And you need a couple of sound effects, which shouldn't be longer than 2 seconds because you don't want any sound to play for like 10 seconds. Like this. Okay. Then we basically have the rendering and the UI covered. Next, the game loop. So before, a game loop was iteration per iteration from user input to user input to user input. In between, nothing happened. We didn't do anything. It was basically frozen. Here, we have a model. We basically have frames. I think in Gozo the default is 60 frames per second. And we loop through some built-in methods. We start with showing the window. You already saw this before. Then we have input events in case the player does something. If not, it's just ignored. Otherwise, it would handle, for example, button press or mouse or whatever keyboard. Then we have the update method, which takes care of a change. So for example, if I jump, I use the update method to do something for the jump. If there's nothing happening, again, next step, draw. Draw is basically, we have all of our parts, we have a background, we have a character, we have the obstacles, and we make sure that they're showing up in the window at the position that we want, in the condition that we want. And then we repeat. And this is the whole cycle. This is one frame. So again, going back to our window, we have an example for the character that we are jumping with. This is all that they do, luckily. We have the coordinates on the top. We remember their size and which way they're facing. And then we have update and draw. And this is basically the code version of what I just explained. We have the jumping logic and we draw them. And if they're jumping, we show the jumping sprite, because in the beginning I didn't have this. And trust me, it looks so ridiculous when you have someone like this and then they go up like this. And then they go down like this. So, jumping sprite. All right, next, state. State is our data. State is, we keep track of the character's positions, the positions of all obstacles, the position of the background, if you want them to move the background slowly in the background. We want to take track our current game score. The played sounds tracking is relevant because we want to also track game over. But the thing is, and this is where I had to adapt my thinking, game over is not a single moment. We keep rendering our frames 60 per second. So whenever there's a collision, I set game over to true, but it keeps on rendering. It keeps on running. So if I play a sound on game over, like if game over is true, play sound, and it's like a donk, then you have. This is when you like the moment when you're developing in the middle of the night and you suddenly wake up again. And then you add a counter for the sound. This is just an example of all the stuff that needs to be tracked. There's actually more, but just so you have an idea. We need to take care of all of this. And since we don't have a database, this is how we do it. All right. Next, user input. This is the only part that is actually simpler compared to the Sudoku because we just have jump. We just press space, we go up. That's it. Gozo methods are button up, button down. In case we want different handling there. We have some other examples. So we want to close the game on escape. We want to restart the game on some other button, and yeah, the jumping. And here this is basically like the simple version of the jumping logic. If you press space, and if they're not jumping already, I also didn't have this in the beginning. So you press space and it goes like, this You are only able to jump when you're not jumping. You play the jump sound, and the jump is performed. More to the jump later. It's so much. Okay, and now the logic part. We just run from A to B, right? We don't even run. It's just there. And we just jump, right? How hard can it be? So I thought about what could I take out without having this talk take for like thousands of years. So we're going to jump, we're going into jumping, and we're going into collisions, and the rest I'm just gonna mention, but it's way more. Excursion 1, jumping. In order to understand jumping, we need to understand the grid. For anyone who has ever worked as a front-end developer, you know this grid, right? You have x-axis, you have y-axis, you have in the top left, so for you it would be like here, 0, 0 coordinates, and then you go like up here and up there. You have 4 corners, you have 4 sides. This is your character, and you have an obstacle moving towards your character, and you want to move your character up and down. So jumping is not increasing something, it's actually decreasing something. And this is when my brain slightly started breaking. But this is basically what it looks like. But jumping is just going up and down, right? Well, physics. This is how I started. Jump height, jump step. We want to reach this, we go up, we go down. This is what it looked like. Yes, I drew this by hand. It's still like, you jump and your character's going. This doesn't feel right. Absolutely not right. So I was like, okay, maybe yeah, there's gravity and stuff. So maybe I had a fall step. So they jump fast and then they fall slowly, and then it looked like this. And they were jumping up and then hovering down, and it was hideous fuck. The problem is, jumping is not this. This is jumping. This is jumping with physics and math. There's a reason I didn't study IT. Yeah. And there's also a reason that the jumping significantly got better after we got something called LLMs. Because now we have stuff like this. We have velocity and gravity and boost, because we have handled the jump input in case blah, 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 and with the button, and we start our jump and we already change so many variables, and then we add our jump boost because this is what makes it look good, and add the velocity, and suddenly we perform the jump and we go up and we go down, and it's like, I partially understand it, to be honest. But it's working. And the jump now actually looks like a jump, and I'm very happy about that. Now I can show you. So, in order to show you my jump, I'm gonna do this. We get our nice little window, and we have our hero. Look at this beautiful jump. We have a high jump and a low jump, and we can jump over the obstacles, which is super nice. But you notice there's nothing more happening here than that, right? Stopping that again and going back to excursion 2, collisions. You thought positioning was hard. Try collision detection. And this is the moment when my brain actually started breaking. So we have front collisions, we have collisions from above, we have collisions from slightly from above in the back. We have collisions because I mean, sure, why not add a flying obstacle, right? So we have collisions below. And I'm going to show you code now. And it looks ridiculously simple. Trust me, it's actually not. This is the whole collision logic. That's all there is to it. The thing is, what you have to understand, it's we have our character. We have the obstacle. They move towards each other. I mean, this moves towards the character. Boom, front collision. X-axis. They overlap. We know it's a collision. Now we jump. So the obstacle moves towards us. We are up. And basically the axes collide. So technically, we still have a collision, but not because the y-axis, like the bottom y position, is above the head y position of the obstacle. And you can have an idea, like you probably have an idea of what I'm going for. But in the end, I managed to make this work in a way that my brain was able to comprehend what I'm doing now. And then this happened. And I'm like, why? Just why? Why? Yep, that's why. And then I realized the sprites are not squares, but the squares are rendered. So if they just like collide by a corner, this is frustrating, you know? You don't want to play a game and then lose because of this. And then you start tinkering around, you add buffers, not too many, and you know, like this is where the rabbit hole starts, because endless optimization, but yeah, these are collisions. So overall, the logic stuff that I didn't want to go into more detail, but it's just so you have an idea how much more it is. We have randomized obstacle spawning. I mean, first of all, we have obstacle spawning. They have to spawn properly. Then we want to randomize it, but we want to have ground monsters, we want to have flying monsters, but that would be boring. So we add flying monsters in different heights to increase the challenge. We have high jumps and low jumps, I already showed you. And they both have to look like jumps. We need balancing. I mean, this is like video game stuff, right? So we need to align the jump height with the increasing speed, with the distance between the obstacles, but also the obstacles need to be properly aligned. You know what I mean? And I already mentioned it, difficulty increase. The speed increases. The obstacles may want to be clustered. If you remember in the browser game from Chrome, you have like 1 or 2 cacti in the beginning, and then you have like clusters of cacti, so it gets more difficult. And then you add a special monster because, you know, you don't have anything else to do, which just shoots through the game, but also plays a special sound, so you know it's coming. You have to do the score counting, which sounds simple, but when you realize you can't go by frames because then the number would increase like ridiculously fast, you have to balance this also. And basically, as profane as it sounds, showing the right sprites and playing the right sounds in the right moments. Okay, finally, our game is ready. I'm not going to show it to you yet because I still have key learnings that George told me to put in. So, building video games. As we saw, it's very interesting. We basically have the same building blocks in a game as ridiculously simple as a Sudoku in the terminal, as well as in this platformer jump and run thingy with Zelda. And if it gets more elaborate, we will still have these building blocks. And we basically build our own MVC design pattern. We have the state, the data in the model. We have the rendering, the sprites, the sounds as the view. And we have user input and game logic as the controller. What we do have to be aware of is performance from the get-go. There's no, oh, I'm quickly going to scale this up and everything's going to work again. It's just running on your machine with whatever you have. The assets are amazing. You can get so many free resources for sprites, for sounds, just free online. And as I said before, developing a game is a never-ending project. You could always add another level. You could always add like some special monsters or whatever. And so for like some side project that you actually never want to really finish, this is a great opportunity. And as I said before, praise be for LLMs when it comes to math and physics. Now, my key learnings regarding my first plain Ruby experience. Rails is so convenient. Oh my fucking God. Rails is basically a mess of implicit magic. And Ruby is explicit. You have to take care of it yourself. You have to follow object-oriented design principles. You have to create your own file structure. There is no generate this for me, and then you have the controller here and the model there and the test file in the place where it belongs to. You have to take care of this yourself. You have to take care of the data structure. I mean, sure, if I write a migration, I also have like to decide where in which tables to put data and how to structure them. But here I just have a state, which is a bunch of constants and variables, and that's it. That's what we have to work with. And same for the boot process and dependency trees. Like I have to require relative everything. As a non-Ruby Rails developer, I wasn't used to that. I was like, why is this not there? Why can't this be found? Like, oh, right way requires. How do I even start this thing? Oh, okay, single entry file, sure. But the nice thing is about actually the debugging, because it's just so short. You don't have like 50 files of middleware stack trace in between. And overall, what I can say is stripping away Rails just showed me how much I love Ruby and how nice the language is. And I'm sorry, but it's really like, it's just the best language. I love it so much. And I think overall the experience made me a better developer. So, yes. Now it's finally time to show you the stuff I've been talking about for so long. This is the actual game. We changed the color for the Octorux because why not? And this is our first cluster. And another cluster. So the speed increases. There's a flying enemy on the ground. And this is the special one. And oh, well, there it is. Thanks, everyone.
Awesome. Thanks so much, Marie. It's great. I think we have time for a couple of questions. Do we? You're open to questions?
Here.
Yeah. There I have one. Yeah.
How in the end you are calculating the score?
It's basically, I'm actually going by frames, like increased frames, but I'm breaking it down to like, I don't know, I divide it by something, and then round it up or down or so. So it's basically going by frames, but in a same number.
I just remember the emulators, yeah, for Dendy, for Sega, when you can slow down the game and do some impossible stuff. And then if we slow down your game, what will happen if it's connected to the real time? Then you can get a lot of scores just with the.
I mean, I added an invincible mode, so you can totally do it.
Yeah, but when it's connected to the frame calculation, then it's fine. Should be fine.
And so nothing in there is actually tied to real time. Everything is tied to frame. Number of, I think I actually used a score as the for the levels. So when you reach, I don't know, like score of 400, this starts spawning for the first time. The clusters start forming. Like in the beginning, you only gonna get like 2 Octoroks as a cluster after I think a score of 400 or so. And with 600, you're gonna get 3 and so on, up to a maximum.
And what about state? Is it more like state machine or just your own states, not the state?
State is basically you don't have a database and you have to keep everything in memory. And
You don't need the
Yeah.
database to make the state machine.
yeah, I know, but you don't have anything. It's just a bunch of variables, as I said. That's it. That's the whole thing.
But do you have these common like methods, like go to the next state? No.
This is something that's I mean, what do you mean by state? Like,
There is the gem called AASM, yeah, the state machine,
Yeah.
Finnish state machine, classical thing.
I mean, in this case, you would have jumping state
There's a
versus
state?
non-jumping state, but that's kind of it. Like you're either jumping or you're not jumping, or game over is also a state.
Yeah.
Like game over, true or false. That's kind of all the states there are.
Okay.
So when I talk about state here, it's more the data that we
Just the variable.
Yeah, yeah.
store and need to keep in memory. So
You mentioned the other ones here. Did you try them?
I had a brief look at Ruby 2D, but for what I was doing, it was very similar. It's just a bit newer as far as I know. And Dragon Ruby looks extremely powerful and super fancy, and it's paid. So I might try it out sometime, but I think Dragon Ruby is also pretty new. At least I just discovered it recently, but it looks very strong. It can do a lot. I think 3D stuff and also.
Dragon Ruby is paid. It's like 200-ish, 300-ish bucks or something like that. But every now and again, they offer it for free.
Ah, nice.
So if you can figure out like in just the right time, then you can get it for free.
Cool.
I don't know if they do that anymore, but yeah.
They do.
There are different tiers. If you go for indie developer, then you have 100, 200 per year. There's a 40 euro for starters, and that one is for free when there's games every once in a while.
There you go.
All right.
Cool. Then
Yes, no, wait.
one more question.
Yeah.
Since Gozo is Ruby and C++, is there some interop layer between where you could call C++ from Ruby?
I have no idea. I know it's written in C++, and this is as far as my interest went.
It's a good call. Right.
All right.
Awesome. Catch Marie later if you have any more questions, I think.